We have quite a history. Savage was founded in 1855 by Richard and William Savage, brothers from New Brunswick, Canada. They opened a foundry in Chicago downtown and made parts for milling machines. Sometime prior to 1900, the company began to focus on making machines for the candy industry. Chicago was the candy capital of America at that time and for several decades afterwards. We manufacture machinery for small to medium-sized candy makers. These are businesses that make their own chocolates and other confections and sell them into their own stores, most of which are multi-generational family-owned businesses.
The Fire Mixer 14 is a tabletop machine that is used to cook and mix ingredients for confections, mostly caramels, toffees, brittles, fudge, and gummies. The Fire Mixer 14 is one of the models that's most inquired about. It's a high volume seller for us. One of the issues that we have with that are the long lead times. So we had lead times that were pushing probably 8 weeks. And then after that, we're maybe on time 50% of the time. We kept doing things the way we were doing them for the past 160 years. There was less opportunity for growth. We knew we needed to change our process, the way we build these FM14s, to be able to get them out to the customer sooner and more efficiently.
What they needed was the ability to be more flexible to customer demand. And that's one of the things that TPS can do with an organization. We can help them achieve that flexibility to meet customer demand and changing market. We believe the best way we can contribute back to society is to help these companies become more competitive. If we can do that, we can help preserve jobs, which strengthens the economy, which is good for all of us. To successfully introduce TPS to your organization requires a lot of introspection, and it's difficult for people to separate themselves from the process emotionally and really ask themselves why we do the things we do.
Well, in the beginning, I couldn't quite grasp how this was going to make things better, because for me, when we were doing batch, the operator or whatever the task was would do the same task on 6 machines, and it seemed to those people, even as well as me, that was a time saver. But what we didn't realize or didn't take into account was that stagnation time of moving the machine on.
Once I could understand the flow, it was a very complex flow, meaning it went from one department to another, but back to the department it came from. So it would actually go from weld to polish, back to weld, to polish, to assembly, back to weld, and then back to polish another time. Very complex flow. The next thing we did was to implement work instructions to help with more consistent cycle times. There were multiple passes back and forth between weld, polish, and assembly, and we removed 2 of those. We were now capable of reducing the lot size from 6 pieces to 1 piece, which dramatically reduced the cycle time. After introducing 1x1 production, we were able to implement a finished goods store and a pull system. In order to create a pull system, there are 3 components we needed to implement. First, we need a line-side store of raw materials. Second, a finished goods store. And last of all, we needed Kanban to control production. Once the sold unit is pulled out of the finished good, it sends a Kanban back to its next area, and it stays within that loop. When that next unit is pulled, it sends a Kanban back to the previous area to that. When that Kanban's pulled, so it's a circle effect that moves up the products. One of the first things I noticed were there were large lots of parts stacked up all over the weld area. This is stagnation, which contributes to longer lead times. When team members are looking for parts, especially like a skilled trade team member like a welder, this is non-value added work, which results in additional instability and productivity loss, where the production times were very inconsistent from one team member to another, or even the same team member doing it over and over. One of the things that we look for in Toyota is, can I see a header behind conditions? I couldn't see a header behind conditions when I was on the floor. So a header behind conditions are very important. We have those set up all over our Toyota plants. For Savage Brothers, they wouldn't know that they were in trouble until they were actually in trouble. And we want to be able to have systems that tell us ahead of time trouble's coming. If we do something about it now, we'll avoid that trouble. This non-value added work resulted in fluctuation, differences between cycle times that result in instability and productivity loss. We organized the area and staged the materials on the carts. We organized each cart and made sure they had the correct materials on them with bento boxes. We introduced next up lanes. Now everyone could see the welder's next job. This also helped see a header behind conditions. Now we are providing the welders with what they needed, when they needed it, and the correct quantity that they needed. With these Kaizens and some additional motion Kaizens, we were able to reduce the fluctuation from 95% to just 18%. Once this was in place, we were able to start delivering 100% on-time deliveries to our customer for the very first time. So the managerial participation out on the floor was very low. I really wanted to get that up higher so that they could see that the floor changes day to day, and the more we're out there, the more problems we'll see and be able to identify ahead of time.
Well, I think the biggest change is that I'm spending more time on the shop floor than I ever did before. And you know, every morning at 8 o'clock, a group of us, we walk the entire floor, we look at the boards that has been presenting to make a more visual appearance of where we are in our process. And I think I interact more with the shop people. Yes, my role is maybe at a different level, but by spending more time on the shop floor, I actually have a better feel for what's going on than I did before, whether we're ahead or behind, what they need to do their job better. They're more willing, I think, to speak to me and to talk about what is going well or what is not going well.
On the shop floor are seeing problems sooner. So rather than being in the middle of the problem, having to deal with it right then and there, we see them ahead of time now. So we implemented systems that allow us to see those problems ahead, and we can react to them much quicker than we have in the past.
A lot of our welders make things completely differently, and we're learning tricks from each other on how to move faster and build better quality products now.
Over time, we learned that TSSC doesn't come in and fix your problems for you, but they teach you how to fix your own problems. And that's so much more valuable because now we can take those learnings, and it's not just about the model line or the FM14, but we ourselves can apply it to different areas of our business.
It's been a fun project, for sure. I've really enjoyed it. I've changed, I've learned things, and I've become, I hope, a better manager for it.
Even though this project started off very slowly, once we got the ball rolling and they saw that the measurable changes were coming, it became more and more fun to come here and work with them. And the more that the ball was rolling on these measurables, the more they were getting done, and we're starting to see them spread their learnings. And that's what really makes it worth its while when we're out teaching TPS, when we see how much we've actually helped these companies and they appreciate it so much.